All right, Algebra 1, today we're going to move into something a little bit different, but kind of a combination of what we've been doing so far. So we're going to solve quadratics today by factoring. So last time, you guys, what we did was we made a picture and we tried to determine, okay, where does the graph cross the x-axis? You know, like where is this place, where is this place? And we said these two places here, sometimes there was 2, sometimes there was 1. You know, an example like this, there would be 1. Sometimes there was none, where you had something like this. But either way, we last time drew pictures to figure out where this occurrence happens, where the x value, I should say where the y value was equal to 0. When y is equal to 0, we have an x crossing, right? So where a picture crosses x is known as the solution. So for today, we're going to find some very handy equations to figure out how to do that without making the picture now. Okay, so we're going to kind of skip the picture and go straight to just solving this thing. Before we do that, we have to be able to identify the square root property, because the first half of your homework, you're going to just use this to solve this. So essentially what you're going to do is, if you have something, something squared, whatever it is on one side of an equation is equal to something on the other side. Could be anything. What I can do to solve this is to take the square root of both of those pieces. I take the square root of either side, and it will cancel out the squaring. All right, so what do I mean by that with the square root property? Well, let's just give an example here so you can get this into your notes. So if I have something like x squared is equal to 25, which I might have given you in your notes, then to solve this, what I can do is I can take the square root of either side, okay? And notice, I want you to notice a couple things about this when I do this. If I do that here, I'm left with, because the square root of a square just undoes that squaring, right? So I'm left with x on this side, which is what I'm always trying to do, is get x by itself. But notice on this side, what I'm going to do here is I'm going to actually have two answers for this. I'm going to have a positive 5 and a negative 5. So it's both positive 5 and negative 5. The reason for that is simple, and let me just explain this because a lot of students get this kind of mixed up at the very beginning. Here's why. If I have 5 and I square it, it's equal to 25, isn't it? But if I have negative 5 and I square that, okay, that's also equal to 25. So when you're taking the square root of some x value, all right, which I did here. I did a square root of an x squared. I didn't know what this was. I have to consider both the positive and the negative. So you will always have a plus or minus answer when you're taking the square root of an x squared term. All right, so that's very important. Now, example 1. Let's just use this idea to solve this. So we have x plus 6 squared here equals 81. Okay, so we're going to use the square root property to solve. And, in your directions on your test, I'm going to tell you that. Use the square root property to solve this. Okay, so what that means is take the square root of both sides. If I take the square root of this side here, I get x plus 6. And here I will get, since I took the square root of an x term, I will get plus or minus, the square root of 81 is 9. Okay, so I get plus or minus 9. All right, so now I got to keep going here, right? So I have to solve for x. So to get x by itself, I'm going to subtract 6 from both sides. And when I do that, I get x on this side is equal to negative 6 plus 9 and negative 6 minus 9. Both of those can be simplified. Negative 6 plus 9 gives me 3. Negative 6 minus 9 gives me negative 15. Okay, so those are your two answers for example 1a. I'm going to do example 1b with you, and then I'm going to have you do example 1c. So for this piece here, I didn't really talk about this yet, but you have to have something squared on the left and then something on the right. So here, I can't just take the square root of everything because it gets messy. So before I take the square root here, what I'm actually going to do is I'm going to get the things that are not being squared to the right side, right? So I'm going to add 3 to both sides here. And when I do that, I'm just left with a minus 8 squared, which is what I want, something squared on the left. And then here on this side, I'll just have a 13. Now I can take the square root of both sides. And so what I get here is a minus 8 is equal to plus or minus the square root of 13. The square root of 13 is not a very nice number. So on this particular case here, I'm just going to leave it as the square root of 13, just so I don't have to deal with the decimals, and I encourage you to do the same. So what I have for my answer here then is I have to add 8 to both sides, right? So you can leave your answer like this. A is equal to negative, sorry, it's positive 8, isn't it? Be a little more clear there. It's 8 plus or minus the square root of 13, and you can leave it just like that. I will accept that as an answer on the test. If you did out the decimal, you would get 11.61 approximately and 4.39 approximately. Okay, so for 1C, I'm going to have you guys try this. Again, we want this squared term by itself, so the first thing you're going to do is divide both sides by 4. Okay, once you've divided both sides by 4, then you can go ahead and finish the problem. So you'll end up with m plus 1 squared is equal to 9. Okay, so I want you to continue it and tell me what you get. Pause the video here. All right, and when you did this out, you should have gotten 2 and negative 4. The way that you got that is you took a square root of both sides. You got m plus 1 is equal to plus or minus 3. So m is equal to negative 1 plus or minus 3. Negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. And you're done. Okay, so that's using the square root property. Now, the next thing that I need to teach you is the zero product property. Okay, so we know from our picture, you guys, we know from our picture that when a graph crosses the x, we have a solution. But what is the y value there where that happens? The y value, you know, in this direction will always be equal to 0. Okay, so what that means is if I set an equation, you know, if I have like a y equals x squared, if I turn that into a 0 equals x squared, I can actually solve the equation. I'm plugging in a 0 for y, and that works, right? So when you factor something, you always get, you know, you always turn some kind of x squared thing into these two pieces. If we set those to equal 0, what that means is, if you notice, like if this factor here was 0, 0 times anything is just 0, right? So whatever makes this factor go to 0 or this factor go to 0 is going to be at the place where the graph crosses the x-axis. So the zero product property is just what makes each factor go to 0. Very simple concept. If this goes to 0 or if this goes to 0, I know that I have a place where the graph crossed the x, and therefore that is a solution. Okay, so let's try that out here. For example 3, I believe your directions here, let me just make sure before I go forward. I believe the directions are solve by factoring, okay? And so here, what you have to start identifying is, okay, is this already factored? Well, there's nothing else we can do with this, right? We can't factor this thing down any further. Since we can't factor it, it must have already been factored. They pulled the 3 in out of something. Okay, so we're going to look at this as two pieces. Okay, each piece that's being multiplied is always a factor. All right, so what makes 3n go to 0? So I can just say, okay, well, when does 3n equal 0? And solve for n. You know, if you divide both sides by 3 here, n is equal to 0. 0 divided by 3 is just 0, right? So 0 is going to be one place that works. The other one is n plus 2. What makes n plus 2 go to 0? Okay, well, you can do that in your head, or you can do this out. If you subtract 2 from both sides, n is equal to negative 2. So at either 0 or negative 2, if you were to graph this right now on Desmos, you would see that that graph crosses. You couldn't use a 0 here, by the way, though. You'd have to use a y. Okay, we substituted the 0 in because we're solving this. But if you used a y there and these n's were x's in your Desmos, because it doesn't matter what the variable is, you would see that that graph crosses at 0 and negative 2. All right, so for 3b, it's a little more difficult. They want you to now, you need to factor this first. Once we've factored it, we could do what we did in 3a. So for this one, let's take an 8 out of both, right? Because 8 goes into 8 and 40, and we can also take a b out. If we take an 8b out, we're left with b minus 5, right? Equals 0. All right, so here, again, this guy, since it's just 8 multiplied by b, the only thing that you can multiply 8 by to get a 0 is 0. So I know 0 is one place. And then what makes this go to 0? You know, what can I plug in for b that make that go to 0? It would have to be a positive 5. If you didn't understand that, you can say b minus 5 equals 0, right? Set it to equal 0. And then add 5 to both sides. So b must equal 5. So at 0 or at 5, you have a crossing for this picture. All right, and again, I encourage you to plug it into Desmos. You just can't use a 0 there. You have to use a y. So you can get the picture of that thing. Y's and x's, right? So this will always be in terms of x and y when you're on Desmos. And then for 3c here, you guys, for this one, what I would encourage you to do is, it looks like you could, you know, take the square root of both sides. This looks like one of those square root properties. But since there's an x term here, it's not very easy to take a square root of that. Okay, so what I'm going to do is, I'm just going to say, okay, well, what if I had x squared, what if I move this over? So x squared plus 10x equals 0. Whenever you're solving, you want it to equal 0. That's an important point, actually. So whenever you're solving a quadratic, you want it to equal 0 when you're solving for the solution. Okay, so for this, I can take an x out of both. If I take an x out of both, I'm left with x plus 10 here. Okay, so what makes this x go to 0 would be 0. And what makes this go to 0 would be negative 10. If I plug a negative 10 in there, I get a 0. Okay, and those are your answers. Those are your solutions. If you graph those, that'll be the place where they cross, the graph crosses the x-axis. All right, so I'm just going to go over, again, the methods of factoring. We learned this in Chapter 8, but we need to always review this because this is all pretty brand new. The first thing is, no matter what we're doing, we can always use the distributive property. That's just saying, you know, what can I take out? What can I take out of everything? Out of every term, right? What can I take out of every term? That's the question you always ask first. Okay, so for instance, an example of that would be like if I had 2x squared plus 4x plus 8, I could take a 2 out, right? So that would equal 2 times x squared plus 2x plus 4. Okay, so using the distributive property to take something out. Then, if I have, notice how this chart's set up. The number of terms is important. So if I have 4 terms, you know, if I have 4 pieces that I'm dealing with, separated by plus and minus signs, you know, doesn't matter if they're positive or negative or whatever. But if I have 4 pieces, you are always going to group. That's going to be your method. Okay, so with 4 pieces, we always group. Then with 3, it's a quadratic trinomial. Okay, that's just saying, you know, if we have 3 terms like x squared plus, I don't know, 2x plus 4, we can use the same example here. Then we're going to use that method where we say, okay, what 2 things multiply to give us 4, add to give us 2. There might not be something here because I just made this up off the top of my head. All right, the difference, then we have the perfect squares and we have the difference of squares. Okay, so perfect squares, remember, follow this pattern where we have, you know, we have something like, we'll use a's and b's here, but if we had a squared plus 2ab plus b squared, that's going to always equal a plus b squared. Okay, this is that thing where we have a perfect square in the first part, perfect square for the last term, and then 2 times their roots in the middle. It'll always be the first piece, square root of the first piece, a, plus the last piece, b, squared. That's when we have a plus sign here. If you had a minus sign, like a squared minus 2ab plus b squared, then it would be a minus b squared. Okay, so we did that last time, last chapter, I believe that was in lesson 8.7. So you can refer to lesson 8.7 if you need some review on that. And then the difference of squares. For the difference of squares, remember, it's something squared minus something squared. When that happens, it'll always be the factors, the first something plus the last something, and then the first something minus the last something. That's what it'll always factor to. Okay, so we'll go through some of those if we need them here on example 4. So for example 4, notice here we have two terms. Two terms means that we're going to focus on the difference of squares. That's the only possibility on this chart. If there's two terms, it's going to be the difference of squares, or it could be the distributive property, right? We always check that first. So there's nothing in common with both of these, so I'm going to go to my difference of squares. Can I write this as something squared minus something squared? The answer is yes. This could be 7 squared minus x squared. Okay, so this thing will factor to, since this is the difference of squares, 7 plus x, 7 minus x. Okay, and I believe what they want you to do is to solve these now. Okay, so we're taking this one step further. This is what we did in lesson 8.7. Again, I encourage you to go back to 8.7 if you need to refresh your memory on this. But now we're using what we did in 8.7 to solve this. So what makes this go to 0 would be -7, and what makes this one go to 0 would be +7. So if you graph that, you would see that this thing crosses at -7 and 7. Okay, so now we're using our factors to tell what the solutions are. That's the new piece. For 4b, notice here that this side of the equation could be a perfect square trinomial. Okay, so let's just check that out real quick. So I see that 81 is a perfect square. I can write that as 9 squared. I know that 25y squared can be written as 5y squared. And then we got to look at this middle piece here. The middle piece is not equal to 2 times 9 times 5y. I know that 9 times 5y is equal to 45y times, if I multiply that by 2, it would have to be 90y for this to be a perfect square trinomial. So what I would have to do then is, well, what happens if I subtract 45 from 81 to make that equal to 0? So if I took 81 and I subtracted 45, I got 36. Okay, so notice I tried it this way. It did not work out for my perfect square trinomial. Okay, and remember, when I'm solving this, I always want this to equal 0 eventually anyway. So I'm going to move the 45 over. And when I do that, I get 25y squared minus 60y plus 36 equals 0. All right, well, let's try it for perfect square trinomial again. This guy squared would be, so if I can write that as something squared, it would be 6, right? So it would be 6 squared. This would still be 5y squared. Now, 5y times 6 is 30y. 30y times 2 does give me my 60y. So I know this is a difference of well, this is a perfect square trinomial, I should say, where I have perfect square, and then 2 times those two pieces. Okay, so I know that this thing is going to factor nicely to 5y, this first piece, with this sign, minus 6 squared. It's that thing twice. If you do not remember how to do that, you can still always take your first term, multiply it by your last term, 25 times 36. I don't even know what that is off the top of my head. And then what two things multiply to give you that, add to give you -60. And you could work the problem that way. And you can regroup it, but that's going to take you a lot of extra effort. So I would encourage you to practice using your perfect square trinomial technique if you notice you see some perfect squares. Okay, so that would be the answer to this one. Oh, by the way, that's not your answer. That is your factor. So what makes that go to 0? Okay, so that's, that sounds kind of hard to figure that out, but all you have to do is set it to equal 0. So don't freak out. So you get 0 here. So I'm going to add 6 to both sides. I get 5y is equal to 6. So then I have to divide both sides by 5 to get y by itself. So y then is equal to 6/5. Okay, so there's your solution, 6/5. And that's in terms of y, because y was given there. So next we have for C. For this one, again, I would make sure that this is equal to 0 to solve. So I have to add 21 to both sides to make that happen. So if I add 21, what I end up here is 36 there is equal to 0. X squared minus 13x plus 36. This does look like it could be a difference of perfect squares. Let's just check it out. I don't think so, since this is odd, right? Since that's odd, it's not going to be, 2 times anything will never give you an odd. So I'm going to just go to my regular factoring technique. So I'm looking for 2 things that multiply to give me 36, add to give me -13. So I know that 1 and 36 won't work, right? Can't get a 13 there, but let's look at 2. If you take 36 and divide it by 2, you get 18. That doesn't give me a difference of 13 either, though. So then let's go again. Let's go to 3. I think 3 goes into 36 12 times. Okay, that doesn't work either. Can't get a 13 out of that either. So let's keep going. I also could do 4 and 9. And there is where I get my negative 13. Okay, if these are both negative, then I know negative 4 times negative 9 is positive 36. Negative 4 plus negative 9 is negative 13. So these are the two factors I can use. Okay, so since I can use those, remember that those are your factors. So I'm gonna erase this, so hopefully you have this in your notes. But it's negative 4, negative 9 is what works. That's what we just showed. So I can write this as x minus 4, x minus 9. Okay, what makes this one go to 0 would be positive 4. What makes this one go to 0 would be positive 9. Those are your two answers. So that's the only thing new, is just what makes the factor now go to 0. Okay, that's the only new piece. And that's it, guys. That's all we're doing for this one. So this one is this chapter here, this 9.4 section, is a big review. It's a big review on factoring from last chapter. Okay, so we're going to practice that factoring from last chapter. And then the only thing new, really, in this one is what makes the factor go to 0. If I can make it go to 0, I have a solution to the problem. All right, we'll catch you guys.